Yes, I'm audible to you.
Yes, sir. Sir, am I audible to you?
Yes, you audible.
Good morning,
Yeah,
sir.
let me start. Yes, good morning. Yeah, let me start. First of all, basic introduce yourself.
Good morning, sir. Sir, I am Shalu Singh. I belong to Dehradun, Uttarakhand. I had done my schooling from Shri Guru Ram Rai Public School, Dehradun. And in my 10th, I have gained 9.4 CGPA. And I have pursued my 12th standard from Shri Guru Ram Rai Public School as well, with an overall score of 89% in my 12th. And after that, I admitted to St. Stephen's College for my bachelor's in chemistry honors, where I have passed it with 9.27 CGPA. And after that, I pursued my master's in chemistry from St. Stephen's as well with an overall score of 76%. After that, I did 1 year training program at ONGC Dehradun, where I was put up at their water lab, which was affiliated by CSIR. And I have hands-on experience on different instrumental techniques like ICP OES, ICP MS, AAS, and after that I started preparing myself for some exams, and I have cleared CSIR net 2 times with All India rank 77 and 83. I have also qualified GATE 2024, and after that I started preparing for many exams, and right now I am giving interview for the same.
Yes, good. Yeah, today is move on the inorganic chemistry. Yes, no.
Yes,
And
sir.
complete. Yes, first is what the basic application of inorganic chemistry.
Since inorganic chemistry deals with the metals and their compounds, so we have like many application of these compounds. They can be used in material sciences, in research purpose, in pharmaceutical purpose, also in medicines as catalyst. In Can be used in polymerization reactions. So there are a lot of applications for these compounds.
Yes, good. First is periodicity. Periodicity,
Yes,
periodic table. Is what
yes,
the
sir.
basic application of periodicity and what the main purpose of periodicity in inorganic and chemistry.
Okay. So, sir, periodicity is basically the similarity in the properties of elements when we try to align themselves in order of their increasing atomic masses. They show periodicity in their chemical properties. That is what called the periodicity. Since we have large number of elements, so it is difficult to arrange them in order of their increasing atomic masses, which was done by many scientists. But after that, according to Neil Bohr, we have to he laid the foundation of the modern periodic table, where the elements are arranged in order of their increasing atomic number. So it leads to the formation of modern periodic table. It facilitates the arrangement of elements. The elements that comes under same group show similar properties, and it also allow us to uh, uh, arrange the elements which are yet to be discovered. We can actually predict some of their chemical properties just by knowing their electronic configuration and by knowing that in under which group it will fall. So that is the one of the major application of periodic table.
Yes, good. Yes, how many elements present in periodicity? What the basic difference? Metal, non-metal, metalloids.
So right now we have like 118 elements in our periodic table, modern periodic table. And if I talk about, we have called metals, non-metals, metalloids, as well as we have certain called lanthanoids and actinoids. Some metals are those that have a tendency to donate electron. They have like electropositive character and less ionization enthalpy, whereas non-metals, they lies toward the extreme right of the periodic table, and they start from group 13 to group 17. And the one of the main thing for non-metal is that they have a tendency to gain electrons, and they have high electron gain enthalpy, whereas metalloids are in between the metals and non-metals. For example, silicon, germanium, gallium, they show the intermediate properties of between metals and non-metals. And then rest we have lanthanoids and actinoids. They lies at the bottom of the periodic table, and they also have tendency to donate electron. But since they all are radioactive, so that's why they are placed at the lower side at the and since in these metals only the last subshell which is filled is F subshell, so according to that they are filled at the lowest. Yes, sir.
Yes, good. Yes, how many elements present in liquid form in periodicity?
Well, there are many elements. For example, bromine and mercury. These are some of the elements that I know present in the liquid state.
Yes. Next, move on periodicity is S block, P block, D block, F block element. What are the differences? Now, how it is work?
Okay, so sir, S block, P block, D block, and F block, they are classified on the basis of the position of last electron. If the last electron goes to the S subshell or S subshell of any of the orbit, then that metal comes under S block or by S block category. If the last electron goes to P subshell, then it belongs to P block. If the last electron goes to D subshell, then it belongs to D block, and if it goes to F block, then they F subshell, then they belongs to F block elements. S block elements generally present at the left side of the periodic table. P block elements are generally present at the right side of the periodic table, whereas D block elements are in the middle of the periodic table, and F block element lies at the bottom of the periodic table.
Yes, good. Next, move on. Second point is chemical bonding. Yes, what is chemical bonding?
So chemical bonding is like the different type of interaction which occurs between the different type of atoms in a molecule or in different chemical species. We have like different type of chemical bonds like ionic bond, covalent bond, and coordinate bond, delta bond, hydrogen bond.
Yes. Is what the difference and what the stability order?
So ionic followed by covalent, then followed by hydrogen bonding, and then we have like van der Waal interactions and all.
Yeah. Next one is chemical bonding is octet rule. What is octet rule?
Sir, it was given by Lewis and Cossell. They both have done their independent research, but since they come to a same conclusion, so we read their theory under the same name, that is Lewis and Cossell theory. According to Lewis, the element share their electrons to complete 8 electron in their valence shell, whereas according to Cossell, the element can gain electron, can accept electron, or can share electron in order to complete the 8 electron in their valence shell, so that they can duplicate the noble gas configuration. So that was called the octet rule, because element tries to complete 8 electron in their valence shell.
Yes. Any exception in
Yes, sir. We have like many exceptions like SF6, which is an example of expanded octet, BF3, which is an example of incomplete octet, and we have like some odd electron species.
yes. Next, move on. And the Vesper theory, theories of chemical bonding. Vesper theory, BBT and MOT. First is Vesper theory, valence shell electron pair repulsion theory. The basic
Yes,
application.
sir. So valence shell electron pair repulsion theory basically tells us about the structure and shape of the covalent compounds. According to this theory, the shape of this covalent compound depends only on the interaction of the valence electron pairs. So according to this theory, the electron that is the present which are present in the valence shell, they tries to align themselves in such a way that the electronic repulsion between them is minimum and the distance between them is maximum. So, but there are certain limitation to this theory because it was unable to explain the structure and shape of the isoelectronic species as well as for the coordination compounds. Whereas VBT, it says that the element where before bonding it undergoes intermixing of the atomic orbitals to form the hybrid orbitals. But there was also limitation to this theory that it was unable to explain the magnetic character as well as color. Then comes under the molecular orbital theory, which was given by Paulings and Mulliken. And according to this theory, the atomic orbitals combines to form the molecular orbital, and the electron present in the molecular orbitals and the electron which is present in the molecular orbital is polycentric. That means it is under the influence of more than one nuclei. And this theory was able to explain that why certain molecule doesn't exist, why oxygen shows paramagnetism, and why certain elements are colored and some are colorless. And it also gives information about the bond order, bond strength. But the one limitation with this theory is that it was way too difficult to comprehend for the polyatomic species.
Yes, next, what the basic difference shape and geometry?
Sir, geometry is basically the three-dimensional shape which the molecule should take, but shape is different from that of the structure because the shape depends upon the repulsion or the interaction which is taking place between the electron pairs of the valence shell. So, shape is decided by VSEPR theory, whereas structure is decided by the hybridization which comes from the VBT.
Yes, what is hybridization? How many type of hybridization?
So hybridization is the intermixing of the atomic orbital prior to the bond formation. And the number of atomic orbital hybridized is equal to the number of hybrid orbitals formed. Hybrid orbitals have lower energy as well as more symmetry than that as compared to that of the atomic orbitals. We have different type of hybridization which includes sp hybridization, sp2 hybridization, sp3, sp3d, sp3d2, and sp3d3. And we have like different type of hybridization and coordination compounds as well.
Yes. Next is MOT. What the basic application of MOT?
Sir, the basic application of MOT includes that it tells us about the bond order, bond strength, bond length, and it also explains that why certain molecule does not exist because they have zero bond order. For example, He2. It also explains about the paramagnetism and the color of the compounds.
Yes, good. Next is hydrogen bonding. Yes, how many type of hydrogen bonding?
So there are two types of hydrogen bonding, intermolecular hydrogen bonding and intramolecular hydrogen bonding. For example, in phenol, we can see intermolecular hydrogen bonding and in water also. But if we talk about orthonitrophenol, then we can see intramolecular hydrogen bonding. Intermolecular hydrogen bonding is between the two molecules, whereas intramolecular is within the molecule.
Yes, good. Next, move on. Next inorganic topic is acid base.
Yes, sir.
Yes, first is basic. What is acid base? What the earliest concept? Ronsted, Lowry,
Okay.
Lewis acid base. Explain one by one.
Okay. So, sir, according to Arrhenius theory, it says that acids are those that release H plus ions, whereas bases are those that release OH minus ions. So, this theory was able to explain that why HCl and H2SO4 is an acid and why sodium hydroxide and potassium hydroxide is a base. But this theory was applicable only to the aqueous solution, but it didn't tell anything about the acidity and basicity of compound in other solvents like benzene. And it was unable to explain the neutralization reaction as well as unable to explain that why ammonia acts as a base. Then we got Bronsted-Lowry theory, which says that acids are proton donor, where bases are proton acceptor. So this theory was able to explain that why ammonia acts as a base because it accepts a proton. But this theory was not able to explain that why BF3 and SO2, like SO2 show acidic character, and as well as not able to align the acids in order of their relative strength. But then there comes the Lewis acid theory, according to which the acids are those compound that accepts the pair of electron, whereas bases are those compound that donates the pair of electron. So this theory explains that why BF3 is an acid and why ammonia is a base. But then but this theory, there was limitation. It was unable to explain the behavior of protic acids, and it was unable to arrange the acids in order of their relative strength.
Yes. Yes, so next is hard acid base concept, hard soft acid
Uh,
base concept.
So hard soft acid base concept, it says that the interaction between hard and hard is more stable, and the interaction between soft and soft is more stable as compared to the interaction between hard and soft. And hard and soft acids and base, they are basically classified on the basis of the polarization. If they are like easily polarizable, they are called soft. If they are like non-easily polarizable, then they are called hard.
Yes, good. Next is inorganic section in nuclear chemistry.
Okay, sir.
Yes. What is nuclear chemistry? How does work nuclear chemistry in chemistry?
So nuclear chemistry deals with the study of the radioactive substances that shows emission of radiations or certain particles that emit during their lifetime. And the nuclear chemistry basically talks us about the different type of radioactive elements, which includes uranium or polonium, thorium, that have great importance in the production of electricity by using the nuclear power plants.
Yes. First is radioactive decay. What is radioactive decay?
The radioactive decay is the continuous emission of the radiations or alpha particles from the unstable nuclei. And once it decay, like once it decomposes, it goes to it like it changes itself to a stable nuclei, and during that course, it releases certain particles or radiations. That is called the radioactive decay.
Yes.
Or in simple language, it is basically when an unstable nuclei changes to a stable nuclei with the continuous emission of radiation or particles.
Yes. Next is nuclear fission and fusion.
So nuclear fission and fusion is basically nuclear fusion reactions are those in which one nuclei disintegrates itself to simpler nuclei, whereas nuclear fission reaction is that where two nuclei combine themselves to form a single nuclei.
Yes. Yes, good. Only basic idea about. Next is inorganic chemistry is a coordination chemistry. Is what the basic application of coordination.
So coordination chemistry deals with the interaction of metal with that of the ligand, and we have like certain application of these coordination compounds. For example, these can be used in research, in material science, as well as a catalyst. For example, Wilkinson catalyst, or they can be used in medicines like cisplatin. Also, many biological importance like chlorophyll is also a kind of coordination compound, and hemoglobin is also a kind of coordination compound between the iron and the porphyrin ring. So yeah, they have a lot of importance in biological system as well as in our daily life. Also, some of the coordination compound also used as dyes.
Yes. First is basically Werner theory in coordination chemistry. What is Werner theory?
So Werner theory basically explains the coordination compound. It tells about the primary and secondary valency. According to Werner theory, primary valency is ionizable and it is satisfied with negative charge ions, whereas secondary valency is the number of is equal to the coordination number, and it can be satisfied with the negative ions as well as with the neutral ions. And secondly, the secondary valency is non-ionizable. When a coordination compound goes to the aqueous solution or as introduced to the aqueous media, then only the primary valency is ionizable, but the secondary valency remains intact. And the limitation of this theory was that it was unable to explain that why coordination compounds are formed, why they show colors, why they show different type of property. None of the questions were answered by Werner's theory.
Yes. Primary and secondary valency. What's the difference? Example.
The primary valency is the one that can be ionized, is also called ionizable valency and satisfied by anions. Whereas secondary valency is equal to the coordination number. It remains intact in the aqueous solution and it can be satisfied by negative ions or by neutral elements.
Yes. Next is ligands. What is ligand? How many type of ligand?
So ligands are basically those compounds that interact with the low-lying energy orbital of the metals, generally d metals. And we have different type of ligands on the on the base of their denticity. We have different types of ligands. For example, monodentate, bidentate, and polydentate. Example of monodentate ligand is halides, halogens, and bidentate ligand is ethylene diamine, and polydentate ligand is EDTA. And they are also classified as sigma donor, pi donors, and pi acceptors. Example of sigma donor is ammonia. Example of pi donor is halogens, and example of pi acceptor is carbonyl or cyanide.
Yes. Next is white ambidentate ligand. What the example of ambidentate?
Sir, ambidentate ligand are monodentate ligand, but they can attach to metal through two different sites, but they use only one site at a time. For example, thiocyanate ion. It can attach itself with sulfur atom as well as through the nitrogen atom also.
Yes.
And another example is nitro, where it can attach itself through nitrogen atom as well as through oxygen atom also.
Yes. Next is IPSC nomenclature. What is IPSC nomenclature?
For IPSC stands for International Union of Pure and Applied Chemistry, and this is the organization that deals with the naming of compounds. So we have like certain set of rules we have to follow that, and then we can give the particular identity to any of the compounds.
Yes. What the main purpose of IPSC nomenclature?
Sir, it is used for the naming of the compound. It can give a specific identity to a compound. If we get to know the name of any compound, then we are able to draw the structure on the basis of the name.
Yes. Good. Next, move on isomerism. What is isomerism?
Sir, isomerism is a phenomena where the molecules that have the same molecular formula but have the different structural format.
Yes. What the basic difference in organic isomerism, organic?
Sir, in inorganic isomerism, we can see isomerism in coordination compounds like linkage isomerism or solvation or hydration. But in the organic, we can see different type of isomerism, which includes chain isomerism, position isomerism, functional isomerism, tautomerism, metamerism.
Yes, good. Next, move on theories of coordination. Yes, we have already discussed the BBT and MOT in chemical
Yes,
bonding.
sir.
Yes, no.
Yes, sir.
What the basic difference chemical bonding theories and coordination theories in BBT and MOT?
Okay. So, sir, in the VBT of the chemical bonding, it says that the uh, molecule, the atomic orbital of the element undergoes intermixing before the formation of any molecule. But in the coordination complexes, VBT says that we have like NS, N minus 1D, and NP. All of them are similar energy. So they undergoes the formation of the hybrid orbitals, and then interaction with the ligand take place. But in the chemical bonding, no ligand interaction occurs. It is basically a simple covalent bond is formed, but in coordination chemistry, a coordinate bond is formed between the metal and the ligand.
Yes. Yes, PBT is a tetrahedral octahedral square planar complex. Yes, now what are the differences?
Sir, the basic differences is on the basis of hybridization. For tetrahedral complex, the hybridization is sp3, and for the square planar complexes, the hybridization is dsp2. And the square planar generally sees when the ligand is a strong field ligand, and tetrahedral seen when the ligand is generally the ligand is weak, or if we have like D10 elements.
Yes, any drawback limitation of BBT?
So VBT was not able to explain the spectral properties, kinetic and thermodynamic stability of the coordination compound.
Yes. Next is CFT, crystal field theory. What the basic application of CFT?
So crystal field theory tells us that according to crystal field theory, metals were classified as point positive charges and ligands were classified as point negative charges. If it is an ion, then that is fine. If it is neutral ligand, then they act as a dipoles. And it says that it gives us the concept of the crystal field stabilization energy. According to this theory, when the metal is not in the vicinity of ligand, then all the d orbitals are degenerate. But when metal comes in the vicinity of ligand, then because of that ligand field, the d orbital splits up into two orbitals, T2g and Eg, uh, according to the field of the ligand. If it is coming from like six phases or four phases, then on the basis of that the energy of T2g and Eg changes, and it explains that why certain compounds have square planar geometry and why have tetrahedral and why some have octahedral and why some, yeah, all it explains. But the major drawback of this theory was that since it assumes the metal and ligand to be charges. So according to that, the halogen ligands, they have like particular negative charge. They should come under the strong field ligand. But it was unable to explain that why halogens are considered as a weak field ligand. So it was unable to explain the electrochemical series of the ligands, and also the coordination interaction between metal and ligand, since it says that the interaction between ligand and metal is purely ionic in nature.
Yes. Next is John Taylor distortion. What is John Taylor distortion? How many type of John Taylor? Static and
John
dynamic.
Taylor distortion is seen when we have asymmetrically Eg filled orbitals. Then we can see Then we can see John Taylor distortion, and it is of two types, static and dynamic. Like it is on the basis of the temperature conditions. If one of the compound is showing static John Taylor distortion at a low temperature, then it can changes to dynamic high at high temperature. If a compound is showing dynamic John Taylor distortion at high temperature, then it can show the static John Taylor distortion at low temperature. And I think these temperatures are called fluxonial temperature or something. So I'm not very sure about the temperature name.
Yes, example of static and dynamic John-Taylor distortion.
For example, I'm not very sure about the static and dynamic, but I can say the copper ammonia complex have significant GTD, as well as the uh, titanium complexes, which we can see from the electronic spectra. This is the case of dynamic GTD, titanium water complex with titanium plus 3 oxidation state.
Yes. Yes, basic idea only. Yes. Next, move on the OMC, organometallic chemistry. Is what the
Yes,
basic
sir.
application of OMC.
So organometallic chemistry is basically deals with the interaction of metal and the organic ligands. For example, carbonyl ligands. And it not only talks about the bond between carbon and metal, but it could be other element also. And it deals with the covalent interaction, more of the covalent interaction between metal and ligand. And the organometallic compounds have numerous applications. They can be used for research purpose in material sciences and pharmaceuticals. And vitamin B12 is one of the first organometallic compound which was discovered. It is the complex between cobalt and organic framework.
Yes. Next is 18 electron rules and ENA rule. What is the difference?
Sir, 18 electron rule tells us about the stability of the organometallic compounds. According to this theory, if it if it duplicates itself to a pseudo noble gas configuration, or it have 18 valence electron, then it is more stable as compared to its other counterparts which have 17 electron and 19 electrons.
Yeah, next is metal cluster, metal carbonyl.
So metal cluster is when we have like a whole organic framework and where metal it sits as a template. For example, in case of crown ethers, they comes under the clusters, and metal carbonyls are comes under the class of metal carbonyl compounds. And carbonyl is a organic ligand as well as a pi acceptor. And most of the carbonyl compounds have research purpose, could be used in pharmaceuticals as well as used in catalytic process and polymerizations.
Yes, next is carbene. Yes, how many types of
Carbene is
carbene
a
and carbine?
The carbene is a 6 electron species which is electron deficient and highly reactive. It is of two types, singlet and triplet. Singlet where both the unpaired electron are present in the same orbital or in the same subshell, same orbital like in the same lobe. Whereas triplet is when the where that is the spin multiplicity of that carbene is 3, and both the unpaired electron are present in different orbitals, and they are also called Fisher and Shrock carbenes.
Yes. Next is catalyst. What is catalyst in OMC? Homogeneous heterogeneous catalyst.
So homogeneous catalysts are those that stays in the same phase as that of the reactant, and heterogeneous catalysts are those that stays in different phase as that of the uh, solution or the element which undergoes catalysis. Example of homogeneous catalyst is Wilkinson catalyst, and heterogeneous is like the nickel, palladium, platinum over the hydrogen, which hydrogen which is absorbed over nickel, palladium, and platinum. That comes under the category of heterogeneous catalyst.
Yes, good. Next, move on organic chemistry. Organic chemistry is basic is GOC. General organic
Yes.
chemistry is inductive effect, mesomeric hyperconjugation. What are the differences? What the
So
stability?
generally we have two type of effect: permanent effect and temporary effect. Under permanent effect, we have inductive effect, hyperconjugation, and mesomeric effect. But under the temporary effect, we have electromeric effect, which is because of the polarization of the field strength. And inductive effect, it operates via sigma bond. It is distance dependent, and it leads to the formation of partial charges over carbon and the key group which is attached to the carbon chain, and it is a permanent type of group. Whereas in the hyperconjugation, the interaction occurs between the sigma orbital of the CH bond. It goes to the partially filled orbital or the empty orbital of the adjacent carbon atom, and then it leads to the formation of carbon-carbon double bond. And the mesomeric effect, it deals with the uh, like any element that have the capacity to attract the lone pair towards itself, or it can share its electron towards the carbon chain. It have two types, plus M and minus M, and carbonyl compounds in acidic and nitro group shows minus M group, whereas halogen can show plus M effect. And it is also permanent effect, and the order of strength of these effect is mesomeric followed by hyperconjugation and then inductive effect.
Yes. Next is intermediate. How many type of intermediate in organic?
So there are many type of intermediates like carbocation, carbanion, free radical, carbene, nitrene, benzene.
Yes. Next is reaction mechanics. What is reaction mechanics? Now, how many type of reaction mechanics? What the main
So
role of major role of reaction mechanics in organic chemistry?
the reaction mechanism helps us to explain the mechanism of the particular reaction. There are many type of reaction mechanism like electrophilic addition mechanism, substitution, nucleophilic substitution mechanism, and elimination mechanism, and electrophilic aromatic substitution mechanism.
Yes. Addition, substitution, elimination,
Yes,
rearrangement.
sir.
Yes. For the example.
सर रीअरेंजमेंट के एग्जाम्पल हो सकते हैं जब कार्बोकटायन बनेगा तो सर इट इज प्रोन टू रीअरेंजमेंट, और एग्जाम्पल इसका हो सकता है इलेक्ट्रोफिलिक एडिशन रिएक्शंस में। आंसर कार्बोकटायन इलेक्ट्रोफिलिक एडिशन रिएक्शंस में बनेगा, साथ के साथ एरोमेटिक इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन में बनेगा। और सर कार्बन आयन हमारा बन सकता है, सर कार्बन आयन जनरली हमारा नहीं बनता है, तभी बन सकता है जब हम E1CB मैकेनिज्म के थ्रू अगर हम जाते हैं तो हमारा कार्बन आयन बन सकता है when the carbon is attached with the highly minus I group.
Yes, good. Today, good work from your side. Okay. Thank you. Nice.
सर मेरा इंटरव्यू मंडे को है सर।
Yes. कल और ज्वाइन कर लेना आप।
2:30।
Yes, full final. Yes.
ठीक है।
Okay. Thank
ओके,
you.
थैंक यू सर।